Welcome to the Aerospace Advantage podcast, brought to you by PenFed. I'm your host, Heather Lucky Penney. Here on the Aerospace Advantage, we speak with leaders in the DoD, industry, and other subject matter experts to explore the intersection of strategy, operational concepts, technology, and policy when it comes to air and space power. This week, we're excited to dig deeper onto a conversation we've been having for the past few years: jet engines. We say it all the time, but it doesn't matter how good an airframe might be or the sophistication of its avionics. None of that matters without capable propulsion. I mean, we think about this every time we hear a combat aircraft roar down the runway, and let me tell you, I always thought about it every time I kicked into the afterburner. But here's the thing, it's not just about thrust. Today, jet engines are also instrumental in delivering another form of power: electricity. It powers the sensors, processing power, data links, and everything else that makes a combat aircraft lethal in the information age. And with that demand for power also comes a major requirement for cooling. Jet engines and their associated systems do that too. We get it off the bleed air. We've highlighted this technology multiple times over the past few years because it's critically important. Too often we take it for granted, and it's a huge mistake. For decades, ever since the Cold War and before, engines have been an asymmetric advantage for America's airmen. But countries like China are pressing hard to overtake America's propulsion advantage. We need to constantly push for what's next. So joining us for today's conversation is retired Air Force Lieutenant General Steve Shepro of Pratt and Whitney. General, thank you for being here with us.
Hey, it's great to be here, Heather. Thanks for having me.
He's got an extensive aviation background with time in the UH-1, A-10, and F-16. And we've also got our very own Brigadier General Houston Cantwell. Slider, thanks for being here.
Hey, Lucky. Great to be here.
Yeah, looking forward to hearing some of your insights from the cockpit. And as our listeners know, before Slider entered the RPA world, he spent over a decade flying the F-16. So, gentlemen, let's start the conversation off with some flying stories. I'd like to hear a memory from each of you about when propulsion really made a major impression on you. I mean, most pilots take their jet engine for granted on a normal mission, but there have to be some times when you really saw that engine provide a make or break capability for you.
Okay, well, I'll start off. Thanks for that, Heather. Both you and Slider know that there are no such things as boring engine stories, right? Just boring ways of telling them. And we definitely all have a lot. The first thing you think of is flying F-100 powered fourth generation aircraft, right? Both with the edge of sustaining 9Gs, and then as the engine upgraded, accelerating at 9Gs. But the story that comes to mind is one that I share with the AFA president, General Burt Field, when he was the commander of the 332nd Air Expeditionary Wing in Balad, Iraq, and I was his deputy, the vice wing commander. And it was back in 2007, and we were at a critical time in what was called then Operation Iraqi Freedom 2. We were fighting against a pretty entrenched adversary, an insurgency. We were turning sorties 24/7. We were getting mortared from the time that we were in the arming area, and then taking off, and on takeoff roll, clearing the fence line, we were in essentially enemy territory, an insurgent territory. And a lot of times we were bombing targets with troops in contact within 10 miles of the base. So it was not only a critical time, but it was a dangerous time. And when you're in a single engine fighter, you said it, Heather, I mean, you want to take the engine for granted. And what I saw, the successful turning of the aircraft and the survivability that the engine provided us, as well as performance, it really was a testament, not just to the engine, of course, but to the brave airmen that were maintaining and sustaining those aircraft. And it was a real salient moment to see that that year, we shaped conditions on the ground to bring in the Sunni awakening in 2008, which really turned the tide of the war. And like I said, it was a tribute to both the engines and the airmen. So like I said, you hit the nail on the head. It's good to take engine performance for granted. That's a huge combat enabler.
Yeah, for me, Lucky, I'll kind of dovetail on General Shepro's comments. My first combat mission in an F-16 was Operation Southern Watch. So we were flying out of Kuwait deep into Iraq. And when you're training, you're like, you practice engine out landings, you figure I'm going to eject in the ocean, I'll just get picked up by an aircraft. But until you get into combat, that's when you really start to think seriously about that engine oil gauge and about all of your engine instruments as you're flying deep over enemy territory. And it really is a testament to the improved logistics and maintenance practices that these single-engine aircraft have overcome over the years. When the F-16 first came out, a lot of aircraft, it didn't earn the name lawn dart for no reason, because early versions of the F-16 had some serious challenges. But over time, the technology and the maintenance and logistics overcame a lot of that, and it is unbelievable what single-engine aircraft are able to accomplish now. And when you look at what happened in Iraq, Afghanistan, our maintenance and logistics professionals overcame a lot of these statistics. If you look at the statistics of these motors over the years, we should have had more engine failures over combat zones. But because we used predictive analysis and we used all the technology at our fingertips, we were able to reduce the engine mishaps in combat environments. And that really is a testament to the professionalism of our airmen. And like General Shepro said, everyone in those combat zones.
Real good.
I really love what both of you said, because you're bringing together both the engine technology and maturity, reliability, and the power of that together with logistical processes, predictive maintenance, and our airmen who do the maintenance part of it. So that's a crucial element, because if you have to worry about your engine, you're devoting brain bites to your engine, those are brain bites you're not devoting to the mission. General Shepro, you came of age in the final years of the Cold War, and you had an interesting progression because you began in the Huey, the UH-1, and then you went to the A-10 and later the F-16. And that era, the years coming out of Vietnam and throughout the entire Reagan buildup really saw incredible propulsion advancements and achievements. I mean, as Slider said, when the F-16 first came out, there were some burps that earned it the nickname Lawn Dart, but today we don't even think twice about that single engine reliability. Back then, America was fielding a broad range of new aircraft, and they needed those cutting-edge engines. Would you mind explaining the factors that drove this cycle of innovation?
Yeah, thanks, Heather. It's a great question. I think that era, and it doesn't seem like that long ago, it was definitely instructive for today. The air dominance imperatives that we had at that time, especially, in that transition from Vietnam to an increased Soviet threat, those imperatives were speed and maneuver, and they really drove innovation. And I think we as an Air Force, we resourced it. When I look back at that propulsion leap, that was what we called fourth generation, and it really was pure OODA loop. And Boyd was instrumental in the Air Force's fourth generation fighter age with the F-15 and the F-16. And of course, it was the acceleration and speed that demanded a breakthrough in an engine for those aircraft, and that engine was the F-100. I would also credit the collaborative learning that took place between the Air Force and industry. We talked about, Slider just talked well about how the engines continue to evolve, more performing, more safe. And that was because a lot of learning took place, and we learned fast, and consequently we advanced fast against what we saw was an evolving threat. As we saw Su-27, MiG-29, those threats come out. It just seems like a short time relatively in my career when we went from that F-100-200 to the -220 to the -229. And the 229 was an absolute monster, if you remember, both on Block 52s and on F-15Es. And not only was the performance amazing, but the learning we got out of that really set the foundation for what would be called fifth generation propulsion. Those properties of supercruise and stealth and the sustainment and survivability that are the foundation of F-22 and F-35 that demanded new propulsion. So again, I wanted to underline that collaboration between the Air Force and industry really has facilitated those leaps and will be instrumental to the leap for next generation propulsion.
Next generation propulsion, we can't get that fast enough. But, staying within the conversation where we're at right now, Slider, you were the recipient of the investment that General Shepro is talking about. You had the amazing opportunity to spend years flying advanced versions of the Viper. Talk to us about these later iterations of the jet as the plane began to ask more from the propulsion, the plane and the avionics, all of the systems, because the combination of more thrust as the Viper grew heavier with the addition of sensors and emission systems, plus it needed better power and cooling to accommodate those avionics.
Yeah, sure, Lucky. So when I was at ROTC, my instructor was the first pilot to get 1,000 hours in the Viper, and that was Dean Stickle. So imagine being an ROTC cadet, getting to hear all of these stories about flying the F-16, doing the fly-off between the 16 and the 17. Back then, the F-16 was day, VFR, heaters, and guns. I mean, the 1980s must have been absolutely incredible to fly this jet. Thrust was absolutely essential to BFM. You had to get the jet into the weapons parameters. I mean, you had to shoot them before they shot you, and you completely relied on that motor behind you. Now, I started flying the Viper in the 1990s, so that's after Desert Storm. Obviously, lots of lessons were learned throughout Desert Storm. So the Viper was kind of in transition. You had the low-altitude Lantern. We were moving out of that and going into the medium-altitude Precision Strike. We were adding all kinds of missions. You were adding suppression of enemy air defenses, so the SEAD mission. And this required new weapons, new sensors. You had targeting pods, electronic countermeasures pods, harm targeting pods. And then you had this common configuration upgrade in the early 2000s that allowed the jet to carry all these things simultaneously. As you said earlier, the weight and power requirements, they're quickly adding up. And then you add all the weapons. You've got the Paveway 3s. Those are over 2,000 pounds apiece. You got the harm missiles, which are almost the size of an F-16 themselves. The jet was being tasked to carry all this at medium altitude. You look at the jet, it's got these short, stubby wings. It requires a lot of thrust to get up there. And then you got to have thrust to be able to maneuver because you got to be able to put some G on the aircraft without falling out of the sky. It was absolutely great having that very reliable single engine up there, but especially from my perspective as the pilot, being able to watch the Viper engine get both stronger and more reliable was really a treat over the years.
More than just treat. I mean, like that's what makes the whole aircraft work, right? And to be able to do so in a way where you just intuitively trust it. You know that it's going to be there when you need it. So, General Shepro, where do we stand today with the propulsion ecosystem, especially through that Air Force lens? Because in the 1980s, when you first entered service, we were in the middle of the defense buildup from the Reagan era, and there was so much new and cutting edge, but we're looking at a different set of circumstances now. The innovation is there, but we've throttled back a lot, pun intended.
Yeah, we became victims of catastrophic success, didn't we? So we won the decades-long Cold War, cut the force structure, we cut investment, and we massively consolidated the industry and the supply chains. But guess what? We were soon in combat again, right? Both in the Balkans and then soon in the Middle East. Slider said something that was really incisive I'm thinking about, and that is how propulsion has really expanded the capabilities of our aircraft. You know, it's not just the thrust, but it was the ability to make the F-16, for instance, in a true multi-role aircraft. It was the ability to make the F-15 into the F-15E. And we've just been able to put roles and capabilities and missions onto those aircraft. And I think that's important because with all the consolidation and the cuts, we were soon in that position where we were tasking our aircraft to do new missions that we hadn't envisioned before, and they were able to take that on. And a lot of it was because we had the thrust and we had the power and thermal management to handle those missions. And it's food for thought because it's a point that we're going to get back to. So, you know, we're involved in the Middle East, we're involved in the Balkans, and it seems like the end of history, according to Francis Fukuyama. And then guess what? Something happened. History repeated itself, or it at least rhymed, right? We saw the return of near-peer threats and the possibility of major war scenarios again. And then you realize, and this is an important point I want to underline, you cannot surge innovation, nor magazine depth. And so this is where we are today. We're talking about now rebuilding the force, the Air Force inventory plan that came out, several Mitchell Institute discussions on this. And part of this is really the defense industrial base. And right now, of course, with all this consolidation and, of course, with impacts from COVID, we're rebuilding that defense industrial base, but we really need to rebuild it to this level of freedom's forge again, where we could scale up and fight long-term fights, because that's how you either win a fight or you deter that fight. So we're still very capable as a defense industrial base, especially in the laboratory, but we have to rebuild that foundation so we could sustain that fight and scale up.
There's so many things, sir, that you said that I think are really important to draw out, because in addition to emphasizing the themes of increased thrust, power generation, thermal management, we're doing that in engines that are becoming more reliable. And also, because they're creating more thrust, they're hotter, but they still need to be able to work within the same size. We're talking about a lot of material science. We're talking about a lot of design that's going on, all within the same shape of the F-16, because in this particular instance, the F-16 hole for the engine didn't get any bigger. It had to remain the same. So that's an incredibly difficult engineering feat. And then what you said about you can't surge innovation. I think that's so important, because so much of what we learned, for example, through the F-16 was through fielding and operating that engine through thousands and thousands of hours. And it's what we're seeing with the F-35 right now, too. And it's that operationalizing that allows us to really, I think, be able to understand not just the predictive maintenance and understanding where things go wrong, but it also is where we begin to learn how we can do that next iteration. And your example of the F-100 engine from the 200 to the 229, I think, is instructive there. But again, we've got to have the production capacity within the industrial base, because it's not just research and development. We've got to be able to learn how to produce and operate these aircraft.
Yeah.
We've taken a lot of risk by, I think, thinning down our inventories. We consolidated dramatically the entire defense industry. Slider, I'd like to bring you back to the conversation to add your thoughts on these calculated risks and where that leaves us now. Because we often talk with JDAM, Mike Dahm, our resident expert on China. And it sounds like the PLA Air Force, the PLAF, is going in a very different direction. So it sounds like the PLAF is more in the 1980s, while we're not quite meeting that scale and scope of effort.
Yeah. Let's be clear here, Lucky. Fighter engine technology has been our American advantage for a long time. Call it years, call it decades. Russia and China, they steal fighter designs. I mean, you look at what they're taxiing around, what they're flying around their airfields, they look a lot like our aircraft, but our engines remain superior.
It's been our secret sauce.
Absolutely. They've always fallen short on engine technology. Now, that's because of our manufacturing processes. It's because of our advanced materials. There's lots of reasons why we continue to have an advantage. Now, moving forward, we've got lots of challenges. We've got big challenges, technological hurdles. And now whether that's an F-47 motor or a motor for an advanced drone, take the latest proposal from Shield AI. This one caught my attention. I mean, this thing, the proposal is that it has a vertical takeoff and then a range of over 2,000 miles. That concept's only possible through a very high-performance engine, high thrust, and then very high efficiency. And as we experiment with new concepts, whether it's CCAs being combined with manned fighters or bomber aircraft, that's going to give industry new challenges. Some CCAs might be expendable, others might not be. All eyes are on CCA Tranche 2. Will it be low-cost expendable or higher-cost recoverable? Either way, I think we're going to need a combination of cutting-edge, high-cost, high-performance engines, along with a larger number of smaller, less advanced engines across whatever our future force looks like. And I mentioned drones. I want to talk one quick note about our MQ-9 fleet, because they've earned quite a reputation. Long endurance, precision strike, these have been the workhorse of our global war on terror. So many additional combat applications of these aircraft, but their engines, although super efficient, produce very limited electrical power. And this low electrical output has really limited expanding the MQ-9, or for that matter, the Global Hawk, to new mission sets like, say, electronic attack or airborne surveillance. So we need efficiency, but in many cases, we need high electrical output to perform many of these advanced missions in the 21st century. no shortage of challenges moving forward.
I'm really glad you brought that up. I've been saying for years that swap C, size, weight, power, and cooling, are physical attributes of aircraft design and engine design. Jill Shepro, putting your Pratt and Whitney hat on now, talk to us about where you see America's jet engine industrial base, challenges and opportunities.
Hey, thanks, Heather. Before I put that hat on, I just want to say one more thing as a rejoinder to Slider's point. I love hearing him say that propulsion is our edge, because it really is in the U.S. I remember my last flying job was commanding general of NATO Air Training Command in Afghanistan. And so I flew everything that the Afghan Air Force had, right? Even Mi-17s and C-27s. So I'm flying, Russian propulsion. And I tell you, there's one thing that would always work and was always reliable and ready, and that was going to be the U.S. engine stuff. We had PT-6s and our C-208s and a couple other platforms like the C-12s. And so it really was an edge of being reliable, sustainable, and performance. And so I'm glad to hear Slider say that. Okay, so the Pratt and Whitney hat. Slider said no shortage of challenges. And to that, I will say no shortage of opportunities. I'm grateful now to still be a part of the USAF propulsion collaboration now on this side. And the imperative is really for propulsion. It's another leap in our propulsion edge. It's going to pivot on adaptive. And I know we'll talk about adaptive propulsion in a second. But it really is our edge. I'm thinking of something that Dr. Gregg, the director of the Aerospace Division at Air Force Research Lab, likes to say. And what he's saying is that aircraft design in the future is going to be flipped. You used to start with the airframe, work your way to sensors, and then finally think about an engine that you would put in. And it's really more and more starting with the propulsion for the reasons you all said. You need to start out understanding the roadmap of power and thermal management and things you're going to need to have that advantage in the long-range kill chain, which is going to be your sensors, it's going to be your reach. These are important points. So I think from the Pratt and Whitney angle, this work, this investment, and the next leap in propulsion is something that really has our focus. And the need is now. It's like you and Slider both said, the adversary is much closer now than it used to be. Now, fortunately, Pratt and Whitney, we've learned a lot from the last 2 million hours of being the Air Force's 5th generation propulsion provider. And it was just like the leap from 4th generation to 5th generation. There's no better tool than experience. And so we've learned a lot from 1 million hours in the F-35, 1 million hours in the F-22. And there's a lot to apply there. And so now, as we look to new levels of range, of penetration, of survivability, of sustainability, and of power and thermal management, there's a lot that we are able to glean and start applying. Again, Heather, though, to your point, it takes investment. Fortunately, the Air Force is looking very closely at this year's funding of both next-generation adaptive propulsion and the F-35 engine core upgrade. And these are both investments that are gleaning next-generation technology and putting them into platforms to make them more lethal, more sustainable, and to give them those attributes that we need for the long-range kill chain. And I'll just make one more point, too, is where the Air Force wants to continue to sustain those aircraft that they want to keep flying for the rest of the century, like your C-17s, ostensibly your F-22s with advanced capability, your F-15s with advanced capability. We can continue not only to provide next-generation propulsion for next-generation air dominance type systems, family of systems, but glean that technology so we upgrade these operational platforms, as we've already done with the F-22, and as you will likely see in those other operational aircraft. And then on a final note, to power the next generation of small engines for those CCA needs that Slider just discussed. Small engines we see as a future, as well as propelling affordable mass. So that's what the Pratt and Whitney opportunities look like that we're focused on and investing in.
It's a really wide breadth of everything that you've covered. One thing I'd like to focus in on just for a moment is the survivability piece, because I think folks don't really appreciate what role engines play in that survivability element, especially as we've moved into fifth and then sixth and advanced generation aircraft, because you have to hide the front of the engine face. And so you don't get to just suck air directly into the core of the engine. There's a serpentine routing to be able to get there. And then you combine that with aircraft that have the ability and the necessity to operate at high angles of attack, where that's not even going straight into the inlet and then being routed to the engine. It's coming in at extreme angles. And so that creates a lot of turbulence and burbles in the air that as it's going into the engine. And so not only do you have to work very closely with the aerodynamic designers for the airframe, but you have to build an engine that's capable of being able to smooth out that flow and ingest it at the rate and the quantities to maintain a stable burn rate and stable thrust. I mean, we've even seen F-22s do tail slides. So reverse it, like it, to me, that is just really says a lot about where your engine designers are and their ability to create the core of the aircraft to provide that other level of survivability.
PenFed checking and savings accounts are here for all your adventures. From
Do you take this man to be your husband?
I do.
to
He has your eyes.
He's perfect.
learn more at penfed.org. Federally insured by NCUA.
So keeping in with this, Sir, Pratt led the way in developing, sustaining the F-119 for the F-22 and the F-135 for the F-35. You're clearly very focused, as you mentioned earlier, on those engines and continuing to upgrade those today and for the future. Could you help understand what is involved with that effort? Because we hit upon the industrial base and suppliers earlier, but aircraft evolve and their engines must too. So how do you approach all of this?
Yeah. I appreciate your last point, by the way. You know, one thing I learned coming from uniform or flight suit over to industry was the complexity of propulsion. You explained it well, but it's mind-boggling. 40,000 parts rotating at 80,000 RPM at over 2,000 degrees Fahrenheit. Like you said, it's a real edge that we have, and it's built by proud Americans that are working in the laboratory and on the factory line to support our airmen in the field. And you're right, it's sophisticated and it's hard stuff, but it is eye-watering to see the capability that we've developed. So to answer your question, like I said, we've continued to learn a lot as we've operated fifth-gen platforms and looking at the next generation. But the survivability and sustainability are key. So I think when I look at the pillars that are going to be differentiators next, one big one is going to be digital as well as AI. And we've done a lot of investment in digital, and this will be key to sustainment. When I look at just the recent next generation adaptive propulsion detailed design review that we had, it was notably digital, like the first digital. And when I look at sustainment, like we're providing now on F-35, we've gone to using digital tools that will underpin things like user-based lifing, right? Where you don't have to wait to the design life of a part to replace it mechanically. That may take more time than necessary or more cost than necessary. Now we can monitor the usage of those different parts, those 40,000 parts, spinning at 80,000 RPM, but we can monitor those. And if we need to fly, like in the necessity of combat more, then we know we can. Or if we can delay an overhaul of an engine, then we can. And that's great impact, great benefit to the warfighter in terms of cost as well as readiness.
Yeah, because then you're not maintaining for just simply based on schedule. You're maintaining and sustaining and upgrading and replacing at need in a way that allows you to manage availability while also mitigating risk.
Yeah.
Awesome. General Shepro. So the F-22 and the F-35 are flying computer systems of the highest order. They are truly information age fighters. Now, we talked about power and cooling demands for the Viper, but the F-22 and the F-35 are clearly in a league of their own. That their demands for more power and cooling are only going to accelerate given what our air crews are going to need to fight and win in the future. Can you talk to us about how you're growing these new engines?
Yeah, thanks, Slider. I think there are two realities besides death and taxes and air dominance, and that is the need for more range and the need for more power and thermal management. It's an imperative. And so for F-35, which, as you know, will continue to be the pillar of the air dominance force, the engine core upgrade that we're working on with the Joint Program Office, obviously, for the services, it's really a critical springboard for that power and thermal management need, especially as the Air Force looks at Block 4 beyond sensors and avionics that will continue to maintain a lethal edge for that platform. Same for the F-22. You know, when you look at the F-35, it's on its fourth upgrade now, but the engine has never been upgraded. It's been such a good engine, and this is coming from Air Force leadership. It's been such a good engine that we've been able to keep turning up the wick, run it hotter to provide more power and more thermal management. But of course, that comes at a great cost, both in dollars and life cycle to the warfighter. And so it's time for an upgrade. And this engine core upgrade, like I said before, it's able to glean next generation investment that we've made to bring the advanced metallurgy, the advanced technology into the engine core upgrade to provide that PTMS, to provide that life cycle, and to provide savings and sustainment in the future. So that's a roadmap for the F-35. And of course, there will be follow-ons to this, but that F-35 ECU really is a springboard. F-22, the same. You know, we just, like I said, did a self-investing upgrade on that with the ECSU system that's providing more performance, that's also providing more power. And it's important that we establish these roadmaps to keep these aircraft continuing to be lethal, continuing to upgrade them and make them better. And so that's a focus of that. And we really do need to fund this sustainment piece. You know, that's a big focus right now, sustainment and munitions. Look at Operation Rising Lion. We're a big partner of the Israeli Defense Force. And when they procure an aircraft, and like they procure both the sustainment and the munitions. So there isn't an aircraft in the inventory that doesn't have the parts it's going to need to maintain top readiness and doesn't have the munitions it's going to need to employ for its mission. And so I think now you're seeing that focus on sustainment. You're seeing that focus on equipping the aircraft as well as that roadmap to keep it lethal.
So do you guys have any specific lessons that you would give back that either the government can make it better for you, help us help you in terms of what are those sustainment lessons? I know you talked about tuning up the temperatures of the motor that gives it higher performance, but I assume that wears out the parts faster. What are some lessons you would pass on?
Right. So I would say it's investment, really, in that collaboration together. So look, from my side, I'm listening to the service member. I'm listening to the need of the warfighter first, as we all are. And the most important thing, of course, is we can maintain that readiness. We can maintain that aircraft availability. That's so important to either win or to deter. And then it's having the right personnel, making sure that we've got the right people that are teaming with the Air Force, with all of our partners. And then it's continuing that collaborative, interactive learning together. We have to do this fast. Again, we talked about the OODA loop early on, and it's imperative we maintain that tight OODA to stay ahead of our adversaries. So I think that just communication is important. And then again, I appreciate this podcast focus on propulsion because it can't be an afterthought or thought of as a commodity. That propulsion, as you all have said, really is the center of current and future capability.
Yeah, absolutely foundational. And in the future, as you said, it's possible that it will be the centerpiece on which future airframes will be designed around.
Yeah.
Which is fascinating. So based off of that, how does next generation propulsion look different than our advanced engines today, like the F-119 or the 135? Sir, you mentioned that you're taking some of the technologies that you've been developing and working for the NGAP program and bringing it back into and doing that tech insertion into the engines we have today. But what does the future engine look like?
Yeah, thanks, Heather. It really is. NGAP stands for Next Generation Adaptive Propulsion. And I underline that because the adaptive piece really is the game changer in the future. It's like having eco mode and sport mode on your car that you don't have to select because the engine's doing all that for you. So once again, with those 40,000 parts at 80,000 RPM, having that all controlled digitally is a huge step. And it really is something you take for granted, but it's not easy to do. But what this leap does, it has total automation across all stages of the engine. So that is where the step change in the range is, in the power and thermal management. And not only that, but we take the learning off of 5th gen, and now we bring stealth and survivability to a new level to really give the edge in the next air dominance theater.
I really liked your analogy between the eco and the sport mode, because that's kind of how I've been thinking about the adaptive piece of it, because by being able to change that specific fuel consumption for an endurance capability or endurance thrust, if you will, that fundamentally changes the ranges or the potential for ranges that the aircraft can go. And when you think about the operational impacts to tanker demand or basing and how far you need to go, I think that we have not fully grasped the implications that next generation adaptive propulsion is going to be able to bring to the fight.
Yeah, you nailed it.
Sir, NGAP is a major leap, and we're living in a time when budgets are super tight. Air Force is pressing forward on a lot of crucial programs. Why are next-gen propulsion efforts like NGAP so crucial? I mean, I'd argue failure is not an option given tomorrow's warfighting requirements and at the pace at which adversaries are progressing. But I'd really like to have your take on this.
Yeah, no, I appreciate it. And Slider, it goes back to why I appreciate this panel, because you have to invest in propulsion. You can't surge innovation. I'm thinking of a book that I assume you guys have read. It's Why Air Forces Fail, The Anatomy of Defeat by Hageman Harris. And it was, a great look at air forces that failed in the last century and why it happened. And I love the study of the World War II example. And bottom line was the Allies just invested more in propulsion, and they invested at scale. And they were sure to have 2 engine for every aircraft, where the Axis powers did not. And again, fast forward to today, it's a great point. Top priority is always responding to the need for Air Force readiness, availability, and lethality. And the next-gen adaptive propulsion really is what gives you that. And it's not only that, but it's the investment. Like I said, whatever the next family of systems looks like in Air Force design, the adaptive propulsion and the next generation investment is going to be critical to that leading edge. But the Air Force is going to have a limited budget. Means are always going to be finite. And so where it wants to save money, it can glean efficiently the investment in that 6th gen, in that next gen edge, and it can apply it to those operational platforms that it still wants to fly at a lower cost. And I named those earlier, as well as the affordable mass side of this, the CCA and the effectors that are going to just be force multipliers for that force. So once again, it's the same message. It comes back to the need to invest, but understanding that even though that investment is expensive, you're really getting a lot out of it, return on investment. Just as an example, I mentioned F-35 ECU. So you're getting the benefits of next generation investment. They're going in that F-35 ECU, next generation propulsion, with next generation propulsion attributes, and you're saving $38 billion over the life cycle of the plane. If that ECU costs, say, $3 billion, that's $35 billion then you have for other things in the Air Force that you need, like sustainment, like munitions, like keeping those other platforms relevant. So again, that's why this point, you can't surge innovation, and you're getting a lot for these next generation investment. I think it's a point that it really merits the focus we're giving it today.
Yeah, I want to emphasize what you said about investment, and you can't surge innovation. I think it's also important to point out that we need predictable, sustained investment.
Thanks.
You can't have fits and starts because you have to manage talent, you have to manage supply flow, and those aren't things you can just cut off 1 month to the next month. And so when budgets are unpredictable, it makes your job impossible to manage all these long lead times.
Yeah, it's a really important point. This is where Air Force and industry partnership really thrives, when you have predictability. And, we want to go fast as well. And that's why we partner with non-traditionals. And it's a good partnership. But ultimately, you want that predictability, like you said, to thrive.
Slider, I'm going to add on that too, because I really think it's not just predictability in the developmental side where you're pursuing these advanced designs. So it's basically R&D. But as you mentioned, you've got to be able to husband the teams. So you've got to be able to make sure that you've got that stable R&D program. But you do have to transition into the engineering, manufacturing, development side where you figure out, how do we produce this? How are we going to manufacture this? How do we train the workforce? How do we get the supply chain? How do we ensure that that base is qualified? How to make sure that we've got the right workers? There is a whole element to this that if we just stay within the research and development phase, we never get to the arsenal of democracy, which is the actual production piece. And so that's the other element where we need to have predictability and growth, is we need to produce these engines so that we can get them into aircraft, that we can get the operational reps, so we can understand the life cycle of the aircraft. So I think what you said expands far beyond just the R&D element of it. We've got to be able to operationalize this.
Thanks, Heather. I'm going to pivot off your last point too, and that is the need to be able to produce. And really, now it's a need for speed, right? And we can do that. We can take a business jet engine like a PW500, we could push the throttle up, and we could modify it as needed, and we could produce them at scale. And so we really are expanding those options. And you talked about manufacturing and additive manufacturing, a very important point. When I go to different trade shows, we'll usually bring models of different engines. And of course, they're real crowd pleasers as they watch an F-135 and an F-35 fly overhead, which usually the crowd completely stops to watch that. And then they come in and say, oh, it's powering that. And we've got a model of it. But what gets a lot of attention is we got this little TJ-150. It's a 150-pound thrust turbojet. It's a little thing I could put right on this table. And that already powers several effectors. And that is one of the propulsion solutions that could be made quickly and can be made at the point of need using additive manufacturing. Like I could put a printer in this room right now while we're talking, and we could print that as a unitary unit. We could hook up some spark plugs, some fuel lines, and we could have that engine running, and we could put it in an effector, and you could do that at the point of demand wherever you need it in the area of operations, and that's thanks to the application of not only sixth-gen know-how, next-generation know-how, but those important new technologies like additive manufacturing. So thanks for doing that, for bringing up that point. And I'll say one more thing. In order to go this fast, we all have to adapt culturally as well. And we in the Air Force will have this conversation about you don't need to test an engine like that like you test and certify an engine on a manned aircraft, especially when you have digital modeling that's over 99%. And everybody agrees on this. It's just, how do you make that cultural shift? And I think we're getting there. But as we get there and we apply digital, we can move real fast. And I think that's an imperative.
No, it's a very important point because that's part of the whole readiness equation. Pratt also powers a vast majority of the Air Force inventory, right? Like you've got the F-15s, the 16s, E-3s, B-52s, C-17s, KC-46s, the AT-6, and even more. And so as we're talking about readiness for the future, we also need to think about readiness for these legacy platforms. What are your recommended solution paths when you wear both your military and your industry hat? Because you've seen both sides of this equation, which is a pretty unique perspective. Beyond just boosting spare parts, what would you recommend?
Yeah, it's a great point. Our top priority is always responding to the warfighter, right? The readiness and the aircraft availability, and especially with readiness informed metrics now, it's keeping those aircraft, the number of aircraft actually available to do the mission. So I think the solution path is, again, it's leveraging across portfolios what those investments that we're making right now. Air Force leaders talk about capabilities over things, the importance of capabilities more than portfolios. And industry needs to apply that language too. So we do. Once again, it's taking those investments we're making and saying, okay, next generation adaptive propulsion or additive manufacturing or digital technology, how do we spread that across all of those platforms that you just mentioned that we're supporting, so we give roadmaps for the increased readiness and sustainability of performance of all those platforms? And I think that's really the way ahead, is continuing to keep those next generation investments going and then gleaning those to both modernize and advance the operational systems that the Air Force wants to fly, and those developmental systems like small engines that will be providing the affordable mass and multiplying the design force that we need to field. This is how you keep the force going. Re-engineering can be prohibitively expensive and problematic, as has been learned on several platforms. And moreover, it's unnecessary when you can take that technology and you can continue to upgrade as we go and keep those operational platforms ready and lethal.
Okay. One aircraft that was not mentioned in that long list that you just went over, but I mentioned earlier in our podcast, was the collaborative combat aircraft. Now, as I understand it, the way in which these aircraft operate, their desired price points, et cetera, may demand different propulsion solutions. What are your thoughts on CCA?
Yeah, it's what I said before, Slider, is that the solutions are there and they could be brought very fast. It's just applying them. And we have a lot of irons in the fire right now. There's a lot of Air Force projects that are going on. There are a lot of things in the classified realm. There are a lot of non-traditionals and startups that we're working with. And so the good thing is that the warfighter has a lot of options right now in which we could go fast.
On both extremes, the high end, high performance, and the low end, lower.
That's right,
yeah.
The exquisite and triple. Gotcha. And I think that's the key, right, is also having that range of options. So from whatever mix looks like from high to low, that we could supply that. Yeah, awesome. And we're all in.
Awesome.
Oh, so great. So where should we be in 5 to 10 years from the propulsion side of things? Sir, as you look to the future, what are going to be those cues that give you confidence that we're giving our warfighters what they'll need to win?
Yeah, thanks for that, Heather, because we got to skate to where the puck's going to be, right? Not where it is right now. As we look at the next 100 years for Pratt and Whitney, since we just celebrated our 100-year birthday, there are some clear signposts for the future. I think on the military engine side, we're always going to be a high-performance engine company. For fighters, bombers, all the enablers that you mentioned, be they mobility, be they training, be they CCAs, weapons, we'll continue to be focused on making engines from 50-pound to 50,000-pound thrust. That's all that Pratt and Whitney does. That's the only thing we do. We focus on propulsion for the warfighter on the military engine side. There might be cases when that's groundbreaking investment or when we're gleaning that to modernize those other systems that we talked about. So that's always going to be the main focus. I think it's important, and we discussed this in 10 years, really expanding our full spectrum propulsion, things that both you and Slider have hit on, investing heavily in our next generation edge, gleaning those lessons and being able to apply them where the point of need is across all of those core missions that the Air Force has, whether it's modernizing, whether it's taking the next big leap. But we really see this area in small engines as being important. Slider, I know, you've got a good history with remote piloted aircraft, and We looked at the future of effectors, and we think it's very important. So there are groundbreaking technologies that I'm glad to discuss, but we're investing in. RDE, rotating detonating engine, hybrid electrics, radically improve the speed and the range of aircraft. And these are technologies that are readily available. Easily within 5 to 10 years, we could be applying these, and they could be realities in platforms. And that raises that capability to a whole new level. Like I said, we're a digital leader. We're going to continue to advance digital and AI, and we're committed heavily to this. As I've mentioned, we'll continue to do that. Additive manufacturing, also the game changer in the future. I mentioned, our ability to print at the point of need. I think in 5 to 10 years, we see us being continually and even more advanced in additive manufacturing, where you see printing at point of need. You see new level of ceramic matrixing and other materials that can maintain higher temperatures, that are lighter, so that continue to give that impetus to that leap. And then finally, we're building global partnerships, kind of going back to your point on our need to scale, on our need to have a robust base to deter or to win the next fight. And we have a great growing global partnership with allied industries across NATO, across Asia. That keeps me very busy, and it's one that we find is very beneficial, very synergistic. And so we'll continue to build that. And this is part and parcel to what you read in the national security strategy and defense strategy about the importance of allies, and we're continuing to build those partnerships as well.
Well, thank you, sir. As you continue the work that you're doing, we're going to continue to keep this conversation at the forefront because, as Slider said, our propulsion capability is one of our asymmetric advantages for America's warfighters. So thank you for making the time. We really appreciate the conversation. It's been great.
No, likewise. Thanks for the focus of this podcast, and thanks for the collaboration that we have with just the experience base that's in this room. The collaboration we have with the Air Force is everything. That's our mission as well. So thanks for including me today.
Slider, great to have you here.
Thanks, Lucky. See you next time.
And with that, I'd like to extend a big thank you to our guests for joining in today's conversation. I'd also like to extend a big thank you to you, our listeners, for your continued support and for tuning into today's show. If you like what you heard today, don't forget to hit that like button or follow or subscribe to the Aerospace Advantage. You can also leave a comment to let us know what you think about our show or areas that you would like us to explore further. As always, you can join in on the conversation by following the Mitchell Institute on X, Instagram, Facebook, or LinkedIn, and you can always find us at mitchellaerospacepower.org. Thanks again for joining us, and have a great aerospace power kind of day. See you next time.